Hello everybody, my name is Jeffrey, and in this tutorial we are going to create a basic game loop. Now there are many ways to create a game loop, but this way I'm going to show you is, well, from my experience, the most easy to set up, and it's also rather efficient. So this is what we're going to use. There are many other ways to create a game loop, and there are ways which are more efficient, but this one is way simpler to execute. So we're going to start off by creating a constructor for our main class, and we're going to leave it empty for now. We're going to create some methods, for example private void init, and this is going to initialize glfw and OpenGL, and a private void cleanup. In the initialize method we're going to create a way for glfw to communicate with us and tell us if it has encountered a error. So create a new variable called private glfw error callback yes. Import it, and we'll also have to create another import. Just remove this line, copy this one, and change this glfw to callbacks, and save. Now what we're going to type in here is glfw set error callback and in here type error callback equals error callback print system.error, and this is where it's going to print out those errors, and that will be in the red text in the console. Excuse me. Sorry. Okay, the next line will be glfw init, and that's it. And the final thing we're going to do is create our window. So private window, and in here window equals new window, and we're going to give it these parameters. So okay, and now we can call the init method from our constructor. Okay, the next thing we're going to do is create a run method. So public private void run, because we don't want anyone to be able to run this method. And in here we're going to create a while loop. So while, and we're going to check for this boolean that we're going to create right now while running, and afterwards we're going to type clean up. So after we're done running, it's going to clean up automatically. Now create this boolean variable. So private boolean running equals false by default. Now we're going to create a start method and a stop method, which can change the value of the running variable. So public void start, and we don't want to start if we are already running. So if we are already running, just return, and otherwise set running equal to true, and run. Stop method now, so public void stop. If we are not running, so not running, just return, and otherwise set running equal to false. We haven't done our cleanup method yet, and this is going to be really easy. So window.hide, just to be sure, and then window.dispose, and that's it for now. Now from our run method we're going to call three different methods: a input method which handles input, a render method which calls all the rendering things, and a update method which is going to update every other thing in the game. So private void input, private void update, and private void render. In the input method we can already type this. Just do this, copy these lines, and paste them in here. And instead of typing break, just call the stop method. That's it. Okay, in our while loop, well, we want the user to be able to render as many times as possible, so we're going to call the render method just like that. But we want to keep input, handling and updates at a constant speed, so that everyone with a computer which is slow or fast runs the game at the same speed and won't have any gameplay advantage because they have a faster computer. The only difference they will notice is the difference in frames per second, but that doesn't really matter as much as your character being able to walk faster or something. So, in order to keep the input and updates at a constant speed, we're going to type a few lines of code. So, long last time equals system.nanotime. I'll explain what these lines of code do afterwards. So, and long current time equals last time. Then we're going to create two doubles, double ns, and this is going to equal 1 billion. That's 1 and 9 zeros, so 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 60.0. 60.0. Then double delta equals 0.0. So, and in here we're going to type current time equals system.nanotime. System, yeah. Delta plus equals current time minus last time divided by nanoseconds, and then last time equals current time, and then we're going to create another while loop. While delta bigger equals 1.0, and in here we're going to type input update and delta minus minus. I'll explain what this code does in a bit, but first we're going to test it out just to be sure that it works. So create our main object, so main equals new main and main.start. And if everything works, we should get our window back and be able to click the close button again. And it does work. Okay, so what we're doing in here is first we're getting the nanotime, which is the amount of nanoseconds since a special date in time. When was it? Well, I believe a certain time, a certain moment in 1970, I believe. Well, if you really do want to know what it represents, then just go to just read up in the Java documents. Then we're going to set the current time equal to the last time. This doesn't. We can also set equal to 0, but I just set it equal to the last time. Just if something messes up, it still has the last time in it. Then we're going to define how much time has to be in between each each call of the input and update. So if we're going to input and then we're going to update, and there has to be a certain amount of nanoseconds in between before we can update and handle input again. And this is the amount of time that has to be in between each input and update. Well, in between each time we run this while loop. Okay, delta is going I'll explain that over here. Then the current time, we're going to set the current time to the current time in nanoseconds. Then delta is going to increase by the difference between the current time and the last time, divided by the amount of nanoseconds that has to be in between each update. Yeah. So delta will be equal to 1.0 once we have reached this time. I hope it makes sense to you. Okay, and afterwards we're going to set the last time equal to the current time so that we can run this while loop again. And then we're going to test if delta is bigger or equal to 1.0. Then we're going to handle update input, and we're going to update, and then we're going to subtract 1 from delta. That's it for this tutorial. I hope I see you in the next one. Bye.